Hey, hi, welcome guys. Welcome back to our channel, which is PyBron. In the last video, we had seen how the independent feature is going to affect to my dependent feature with the help of the visualization. In today's session, what we are going to discuss in this session, basically, I would like to, whatever I showed you with the visualization, I am going to implement all those things with the help of the code and with the help of the numerical method. So whatever it is displaying, whether those things is correct or not. Okay, and also I will try to build simple linear regression algorithm with the help of the one feature, and later on, if you want to build the simple linear regression with all features separately, you can do it it is up to you how good you are in that. Okay, so basically what I'm going to do, I'm selecting one feature, CRIM, independent feature column, and I'm going to create my independent and dependent feature. So I created my x is basically independent feature and y is my dependent feature, right? And now I'm going to call linear regression method of sklearn. Okay, so I'm going to call my linear regression class basically, and I'm going to create an object of linear regression class. Okay, and at the linear regression object, I'm going to call the fit method, which will fit, in which we are going to fit my independent and dependent dependent feature basically. So x and y I fit, and I'm going to check intercept. I'm going to check intercept and coefficient. What is the mean by the intercept? First try to understand. Okay, so if you know the state line equation, then it will be very easy to understand, guys. Just try to understand. In class 5 or 6, you have heard about this equation, mx plus c. Okay, just try to relate these things. Okay, so what is y? It's an independent feature. Okay, so y is my sorry, my bad, y is dependent feature, and this m is nothing but it's a slope, guys. It's a slope. So here coefficient is nothing but slope. Okay, so this is my slope. Okay, this is my slope. And what is the slope? Just try to understand. So here 1 minute, guys, 1 minute. Okay, so here minus 0.415, and here is the x, and plus c is my y intercept. Okay, just try to understand. If I'm going to draw a straight line, you can understand betterly. So this is my m, this is my nothing but this is my m, and this is known as the c. It's a y intercept, means my straight line. Where is my straight line is intersecting to the y axis, that is known as the intercept. Got it? So up to this, no doubt. So you understood what is c. So c is 24.03. So in this case, where my straight line is going to cut to y-axis, 24.03. I do this 24.03. Up to this, no doubt. Okay, now just try to understand. If you go bit up, if you go bit up, just try to go bit up. Okay, so what I'm going to do, first CRIM value is 0.00632. So what is the price here, guys? 24.0. Okay, just try to put this 0.00632 in this equation. If you will try to put this thing in this equation, what the output I will get? Okay, I already kept all those things here, guys. So if you can see this equation, y is equal to, I kept this. Okay, so I kept 0.00632, and I am trying to find a prediction for the y. So I am getting 24.03. And what is the actually y value, guys? There, just try to understand. Just go a bit up. Okay, let me go up. Okay, so here my actual y value is 24.0, and what I predicted, means what my model is going to predict. Okay, let me show you. My model is going to predict 24.03. Is approximately same. It is approximately same, means what actually result are there and what my model is predicted. So I can say it is giving the correct response, right? Right? Okay, no doubt. Okay, so fine. Up to this, my model is working fine. Now, okay, let me clear this. So next is what? Just try to understand, guys. Okay, so okay, no doubt. I can able to now, this is though my mathematical calculation. This I did means mathematical calculation. Now you can call the predict method also. With the help of the predict method, whatever we did, this is manual process, right? And now I want to see what is my model is going to predict. Okay, so what I'm going to do, I'm going to create a separate data frame like xnew pd.data frame, and here I'm going to pass that value 0.0063. okay, so I created one data frame and here I'm passing that 0.0063, and this is my data frame. And now I want to see what is model is going to be. This is my model object lm, and I'm going to call this predict method, and in this predict method I'm passing this data frame, and what the output it is giving 24.03, and what you calculated manually 24.03. Everything is same, and your model is also giving the same output, and what is the actual value 24.0, and this is also 24.0, right? So you can see your model and actual result is giving the correct output. It is the sum of the cases, but if right now we check for only one thing, right? So if you want to check for the another data, that is also happily you can do, and you can try to check whether it is giving the correct output or not. Okay, now sometime in some of the cases, if you will check some of the cases, your y value or predicted value will not match with the actual value, right? Means what I'm trying to say, just try to understand guys. So what I'm trying to say, just a minute, your predicted value is like this, whatever I made it with the red line, this is my predicted value, and your actual value, corresponding actual value is with the blue color, okay? So sometime your blue color is on your predicted value, or sometime it will be something different, right? And what I'm going to try to build, I'm trying to build one linear regression. Linear regression is nothing but best fitted line. Okay, just try to understand, this is your predicted value, but this is your actual value. Okay, I'll make a different color again. Okay, this is your predicted value, and this is your actual value. So there is just some difference are there between these 2 points. So this is known as the error term. Okay, so here is my y cap, and this is my y actual. Okay, so if you can able to correlate, so y cap minus y is nothing but it's known as the error term. It's nothing else, it's known as the error term. Okay, so in we as a data scientist, our job, we have to minimize the error. How good your model, your model accuracy will depend on this error term basically. So how can you reduce, how much you can reduce this error, that much good your model. That's all. Now how we are going to see these things, so basically in order to do these things, we are going to draw a least square line. So how we can draw the least square line? Basically, in order to draw the least square line, we need two things. If you can see this diagram which I plotted here, this is my minimum point, and this is my maximum point. So in order to draw this line, we need two things, right? One is minimum point, another is maximum point, guys. So what I'm going to do, I am going to create one data frame, and in that data frame, I am going to calculate my minimum point and another 1 minute, guys. So in order to draw this straight line, I need two things. One is the minimum point, another is the maximum point. So what I'm going to do here, I'm going to create a data frame of CRI because it's a simple linear regression. So it will depend only one independent feature. Okay, CRIM. So I am trying to take a minimum point and maximum value of CRIM column, and with that I create a data frame, and I'm checking that data frame. Here is the minimum value is 0.0632 and maximum value is 88.97.620, no doubt. And now with this xnew, whatever data frame I did, and with that, if I'm going to predict what will be the predicted y, what should be my predicted y, so I can call just predict method, and I can pass here 1 minute, I can pass here my x new. Okay, so I can see my predicted output is this one. Now I can happily draw my straight line. So because here x value is 0.060632. So let's suppose my x value is this one, 0.00632. And what is the appropriate y? 24.030. So this is my, you can say this is my, okay, I'll draw here, don't do there. Okay, so this is my x is 0.00632. okay, so now, and what is the appropriate y? Y is 24 point something, so might be it will be here. So my, this is my point. Okay, similarly, what is my next x? Max x, 88.97. so 88.97, let's suppose it will be here, 88.97. okay, anything. And what is the appropriate respective y value? Minus 12 point something. So minus 12 point something, it will come down. So if you can draw a line, straight line, it will be like this, right? This is the appropriate straight line. Okay, so now I'll draw this once again, don't worry. Okay, so basically you can see here, so if I want to draw a straight line, so my straight line will be like this. So this is my x value, 0.00632, and this is my y value is nothing but 24 point something 03, and this is my x value, maximum x value is 88 point something, right? 88.97, and this is my y value is something, will be like this. What is that? Minus 12.908. No doubt, up to this we are good to go. Okay, we can draw the straight line. Okay, cool. Coming to the down, let's come down, and I am trying to plot a scatter plot. Means I'm going to plot how the data is going to how my actual data is going to scatter based on this straight line. Okay, so what I'm trying to do, I'm just plotting the scatter plot with xcrim, just now we did, right? And I'm going to draw that line on the top of that scatter plot. So you can see it's a approx, means it's try to fit that straight line on the top of this data, right? There is error, no doubt there is error. So that error we are going to find it, how we can reduce that error, that we will see. But as of now, we can draw a straight line, right, on the top of this, right? Okay, cool. Now model, how good your model, that you have to check, right? As it's a simple linear regression, right? So how good your model, so how you can check those things? So you can check with the help of the p-value. Okay, p-value, how the p-value is going to help you, right? So for that, I can again see everything is going to run around this equation, guys. Y is equal to mx plus c, nothing else. Y is equal to mx plus c. So what is the m? M is nothing but intercept. C is what? C, sorry, m is the slope, c is the intercept. Okay, so you can see here what you can say, this is my intercept, means this is my c value, this is nothing as c value, and this is what? This is my m value, right? Okay, if you are taking, as here level of significance is not given, so you can consider 5%. Okay, 95% you are confident about your model, 5% is the chance where your model will get failed. So 95% your level of confidence, and what is your critical value then? 5%, means 0.005. okay, no doubt, 0.05. got it. Now just try to understand what is this, just try to understand what is intercept, what is CRIM. Okay, and okay, so here, in order to set the p-value, in order to do the hypothesis testing, we need two things. One, we have to set null hypothesis, and another thing, we have to set the alternate hypothesis, guys. So what do you mean by the null hypothesis and alternative hypothesis? Okay, we'll come in that point. Before coming to that point, I would like to show you one more thing here. What is that? We have to check the R square value also. So what is the R square value? R square value is nothing but it is giving the idea how good your model. Okay, so it is saying 0.15, means 15%. It is saying, means if you are going to predict the Boston land price based on the CRIM, so 15% you can say it's giving the correct output. 85% chances are there that will be wrong data, wrong prediction. Okay, so as good as, means you can say if you having the good R square value, your model is good. Again, R square is not a factor which is going to judge your model. Again, I am saying, as of now, you just keep R squared is the factor which is going to evaluate your model. But if you, later on I'll show you, if you are going to incorporate more more features, then your R squared value will get automatically increase. So R squared is not a correct factor to optimize your model or to analyze your model. It's just a factor, but I can say what is the R squared value. R squared value is nothing but it is going to say how good your model. Okay, so as of now I can say I'm not getting correct means good R squared value, right? So let it to be as of now, let it to be. Now what I'm going to try to do here, I'm going to do some hypothesis testing, guys, here. Okay, so as I did not make here, I'll show you how to do the hypothesis testing here. Okay, because it's a very important factor here, because as a data scientist, your job to check whether this intercept are correct and whether this factor, this feature I have to incorporate to the model building or not, right? So how you can check these things? Okay, just try to understand, just see me, just try to understand. Y is equal to, what is the m is the intercept, m is this one. Okay, so 1.17, if you can say something 10 to the power minus 19, something very less value, you can say very less value. Okay, plus intercept. Okay, this is the x here, and plus intercept. What is the intercept here, guys? 1.34. Okay, and something I'm not considering about the power or indices. I'm not considering those things as of now. Okay, let me make a different color so it will be more understandable. Okay, so in order to do the hypothesis testing, as I told you, you have to set two agenda. One thing, your null hypothesis, and another thing, your alternative hypothesis. Basically this data is taken from the one population, right? It's not a correct complete data set, it's taken from the population. What is population? Just try to understand here, just try to understand. This is my population. I don't know what is the data here, I'm not knowing. And my null hypothesis is saying, CRIM having no relationship with the price, having no relationship, right, with price, having no relationship price. This is my null hypothesis. Null hypothesis is saying CRIM having no relationship with price. Got it? So no relationship in the sense of what do you understand by the no relationship? Means this m part is equal to 0. Means basically I can say slope is equal to 0. If slope is equal to 0, then what is the possible line? You can say it's a straight line. It's a straight line. You can say if m is equal to 0, then y is equal to c, and y is equal to c means it's a kind of a straight line. Okay, it's a kind of a straight line, right? So this is my null hypothesis. Okay, and what will be the alternative hypothesis then? Alternative hypothesis is my m is not equal to 0. M is not equal to 0. Sorry. Alternative hypothesis means if it is not equal to 0, means it having some relationship with the price, right? It having some relationship with the price, right? So we have to check these things. Okay, so hope you clear with the hypothesis, right? I'm trying to check these things with this. Okay, let me clear this diagram, and again I'm going to build this. Okay, so what I'm going to do, y is equal to mx plus c we did, right? And my null hypothesis is saying m equal to 0. M equal to 0 in the sense of price having no relationship with the CRIM, means no relationship. Okay, and what is my alternative hypothesis then, sir? My alternative hypothesis is m not equal to 0, means having some relationship. So we have to check these things. How we can check? Okay, how we can check? Okay, as in your case level of significance is not given, so you can take anything. As of now I'm taking standard level of significance. I'm taking 5%. My confidence level is 95%, means I can say I am 95% confidence in my model, whatever it is going to predict, or I can say 95% I am sure that it is going to you can say it is going to depend, it is going to affect to my price, right? So how we can check? First thing, right, it's a very important thing, right? So here your intercept value, okay, let me show you this. Intercept value is less than, okay, what is your p value here? 0.005, right? P value is 0. Okay, no problem, no problem. So just try to understand, if your coefficient, you can say coefficient is less than p value, then you can say this column is going to affect to my price, and if it is the case, then you have to reject the null hypothesis and you have to accept the alternative hypothesis. And what is the alternative hypothesis, guys? Here, key alternative hypothesis is saying your x, means CRIM, is going to affect to your price, right? So if what is the basic funda, I'll prove it in the next video. I'll prove it why I am saying these things with the help of the t value, t statics. I'll prove it how it is going to, I am going to say it is, right? So up to this, till now, you just understand, if your coefficient value is less than p value, then it is going to affect to your target column. Hope you understood, guys. So for this video, this much only. Hope you enjoy this video. I know this is the critical things, this is the very conceptual things, but if you will do the practice, then it become easy, guys. It become easy. It's not a hard and fast rule. It's not a rocket science at all. You have to do the practice. How many times you will do the practice, that much you will get the confidence in this topic. Okay, hope you enjoyed this video. Keep on learning, stay tuning with us. We are coming with some updated videos here. Okay, so meanwhile, just I can say goodbye, and please do subscribe to the channel so that you will never miss our update. Thank you, guys.